Hello, Professor. This is our team Cyber Guardians, and myself is Venkatram Adlagadda, and my other teammates are Sai Kumar Gogneni and Ramyasri Kalpala. Here, our topic is authentication of fitness tracking using the Bluetooth Low Energy, and Mr. Sai Kumar will take the lead.
Yeah, thanks, Venkatram. To start with introduction, our topic is authentication of fitness tracking using Bluetooth Low Energy. With the evolution of Internet of Things, many smart gadgets that we generally use, like smartwatches or any fitness bands or any smart sensors that we use in our autonomous vehicles. All this is possible because of the Internet of Things, so that these smart gadgets, they can communicate with each other through internet. Can you please come to next slide, Vikram?
Yeah, sure.
With our present topic, Bluetooth is mainly used as the protocol to connect for the connection between the mobile phone and the fitness tracking device, that is our smartwatch. Uh, so, uh, after pairing between this mobile and smartwatch, the user activities are certain user activities like sleep tracking, daily, the steps taken by the user, or the sleep duration, the activities are like outdoor walking, and any health suggestions, and monitoring of blood oxygen of the particular user. All these activities are all these activities are tracked by these fitness tracking devices. In this paper, we are going to discuss about the vulnerabilities in the existing techniques and the privacy concerns of the user data that these smartphone applications are using to give suggestions to users. Yeah, so we will go to related work to review more. So these fitness trackers are evolved. Most of these fitness trackers came into market from 2013, and there are many security flaws in the current fitness trackers. Any person who is having a smartphone can directly connect with our smartwatch if their Bluetooth is on, and if we click on the pair button. So it will automatically get connected to that, since the connection is through Bluetooth. And so to minimize the risk of user data, we are going to explain the some techniques on authentication mechanisms, so that to protect the user data. So in the next slide, we are going to discuss about how the connection takes place between the smartphone and the fitness tracking gadget. That is, in my case, I have done an experiment using a smartwatch, ColorFit Pro. So when we try to connect with the smartphone, the process goes on like this. When we have to scan for the device in our smartphone. So it will show all the available devices, and we will select the particular device. Like in figure 3C, you can see that we have seen a device ColorFit Pro 3. So and we can see the same when we click on pair, we will get a pop-up on the smartwatch to connect to that smartwatch. And when we make a request to that smartwatch, we will get the confirmation with the MAC code, that is 03D4 in this case. So when we click on that green arrow, this pair becomes successful, and this smartwatch is connected to smartphone, so that we can see we can see everything in the smartwatch. And can you open that logs folder once, Venkatram, so that we can see the
Sure.
So this is the logs file that will be generated from the mobile application for that particular noise fit application. So yeah, we'll come from the beginning. Go to the top.
Yeah.
Yeah, so here you can see that the device name, SP name is device name. So the length of this device name is 12 characters, starting with 31 and ending with 03D4. So we have to select the device in our mobile so that it will get automatically connected. So the mode here is auto connect, and uh, if you see here, the phone has paid list. If we click, I mean, when we on the Bluetooth, it will show all the available devices for the connection. So here we have, here it is showing 3 devices: Realme Buds A2 and ColorFit Pro 3 Soundcore Play 2. So these are the available Bluetooth devices, and I have requested for pairing request with this ColorFit Pro 3. So that it will get connected to the smartwatch. And there are some encryption methods. If you see here, the phone Bluetooth switch is closed. So when we, unknowingly, when we, click on the Bluetooth button, the connection will, the connection will get disconnected. Can you please come down a little and get on?
Yeah.
So if you see this JSON format, these are this is the JSON structure, which is explaining all the available functionalities in that smartwatch. We can get notifications related to Snapchat or Telegram or all other applications mentioned here, and we can the objects which are having true will pop up the notifications related to that particular application in our smartwatch. Can you come down a little down? So these are all the functionalities existing in that application. A little down to the end of this JSON object. Yeah. So here, if you see, the encryption is enabled and it is checking the health of that application. And so in this way, our data is encrypted, and if you see here, the auto length is mentioned, and it is 12 characters, starting from that 31 and 04. We will go back to the design diagram so that we can see more there. So this is basically the design diagram, and it shows how the connection mechanism works and how the connection takes place between the smartwatch and mobile phone. So if we want to look at the attack surfaces, so the possible attack surfaces can be smartwatch, user data in the fitness application, and user data. Mostly this data will be stored in the backend server, so this can also become attack surface without proper security policies. And the key attack vectors will be weak keys that we use for the pairing of this smartwatch and mobile, and weak passwords and weak encryption methods between these two devices. So yeah, Ramya will continue from here.
Yeah, thank you, Sai. And now coming to my point, we are going to discuss about the Bluetooth Low Energy Protocol Stack architecture. In this, we are going to see mainly about the pairing between the mobile application present in the mobile phone of the user and also the fitness tracker that has been analyzed in the previous case studies. And we can see here the architecture in the above PPT, and it consists of mainly 3 layers. And it has mainly 3 components that would contain various models as well as the layers. And these 3 components are mainly controller, host, and as well as the application. Well, coming to the controller, the controller would contain all the low layers of the Bluetooth low energy stack, and in this mainly it consists of a physical layer, and it is mainly responsible for modulating as well as demodulating the signals and transferring them into the same digital format. And it also mainly allows the broadcast communications, and whenever the connection has been established, the connection mode will be enabled, where the central device will be referred as a master and the peripheral device will be referred to as slave, and then the rest will be continuous in a master slave model. And coming to the host, we can see the host involves mainly in two aspects, that includes the profiles and as well as the protocols. And in this, the profiles utilize all the functionalities that are provided by the protocols, and mainly its procedure is mainly depends upon the Bluetooth low energy devices that can communicate with each other, which can be displayed with the energy access profiles, which is responsible to pair up and to connect with the other devices and to discover the devices which are securing the same and performing them in the same way. And we can see at the top, it's an application in which it is present at the top of the architecture, and that would represent all the applications that tend to use the functionalities of the Bluetooth with the low energy protocol, and then by getting the access to the application program interface. And this all we can see here in the PPT in the form of the architecture. Coming to my next slide, we are going to discuss about the tool, how it gonna used in our studies. And BLE tool is nothing but a Bluetooth low energy tool. It is an application tool that is used in developing the Bluetooth low energy accessories, and it is mainly used to avoid the secured vulnerabilities that is present while establishing a connection between the mobile phone and then devices. In this, it is mainly used, it is a subset of the Bluetooth, and its main purpose of this tool is to support the device and to tend to longer durations. And this the controller would contain all the lower layers of the Bluetooth and uses the low energy stocks. And coming to in this, the long-term keys will be generated, and the device would generate an elliptic curve Diffie-Hellman. This would generate a public-private keys pair, as Sai has explained the different keys that we have explained, that we have gone through in our case studies. And after generating the keys, the devices tend to exchange a public keys, and they will compute the defeat. And the generic attribute profile is responsible for organizing the Bluetooth low energy connections by utilizing the attribute protocol, which is one of the virtual transport mechanisms, and the data is transformed to it. And also the protocols and the profiles are used in the adoption protocols. And in this, the controller at the lower levels will use the Bluetooth low energy stacks. And while coming to the conclusion, okay, in this whole paper, we're gonna see about the pairing between the mobile application present in the mobile phone of the user and the fitness tracker that have been analyzed. In this, mainly we have used two different methodologies. First one is Bluetooth hoop lock and then Ubluetooth hardware. And Ubluetooth hardware is nothing but an monitoring mode to analyze the data. Okay. In this, the communication of data between the honorable devices and the mobile phones, we can see that in the whole PPT, and this can be avoided by using and monitoring the mechanisms with the different mechanisms. Okay, that's it for today. And these are the different contributions that we have done with our paper. So thank you.
Thank you so much.
Thank you.